Today we'll discuss about cloud computing. What are the futures of cloud computing? Then different vendors, service models, deployment models. What are the disadvantages of this cloud environment? Then we'll discuss about virtualization that is responsible for cloud computing basically, and different types in that, advantages and disadvantages of that. Then different components of specific to AWS and shared responsibility model, and then I'll give you a small demo of the dashboard. And at last, we'll discuss about the threats of cloud computing in 2021. Okay, or cloud computing, cloud attacks, basically that has been happened in 2021, and how do these attackers try to find any kinds of misconfigurations in internet? Okay, how do they scan for this? So I'll explain the mechanism behind that. Okay, so that is agenda for today. Now, to go now, what is cloud computing? Like, what is the idea you are having about cloud? Or many of them might be working in on-premises, right? Now, while moving to cloud, what is the major difference we have observed, or what do you think when you say cloud computing? What is your understanding about it? Anyone can give your thought about it?
There, there won't be a physical infrastructure like routers, switches, firewalls, servers.
Yes. Yes, correct. Everything is accessed locally over the internet. So the main advantage of cloud computing is that it's on demand and self-service. On demand in the sense, whenever you want to launch an instance, or whenever you want to launch an VM or a database server, or any storage service, okay, it is available on demand, and you can just buy that for a specific period, and you will pay billing accordingly for a specific month, or for a specific time period, right? Now you can access all these. Can you please mute someone? Can you please mute your microphone? I hear a lot of background noise. Okay, thank you. Now we can access all these services. It can be storage, database, network, or applications over the internet. Okay, so we don't have access to the physical infrastructure. Physical infrastructure is present with the cloud service provider like AWS, Amazon. These are all public cloud service providers, right? So they have all this hardware. We will be accessing these hardwares from the data center. Okay, now cloud computing relies on sharing of resources to achieve economics of scale. So if we want to launch our own services, then we need our own server room or our own data center for our company, right? Then we launch our own services there. Uh, like if you are getting a client, say we got a project, and the project will be starting in say next 3 to 4 months. Now from today, you need to make sure what are the hardware requirements you need for that client, right? Accordingly, you need to deploy it in your data center. Now when you come to cloud, this process is this everything is taken care by the service provider. Just you need to opt what kind of resources you want, or what kind of capacity of virtual machines you want. Okay, that is the thing which you need to choose. Rest everything is taken care by the service provider. Okay, then it has pay as you go model. So whatever you are using, for that you will be paying. So for example, I'm using an EC virtual machine instance for say for 1 hour. Okay, and after that 1 hour I'm stopping that, or I'm terminating that. So you'll be paying for only for that 1 hour. If you take a traditional data center, if you use or if you don't use, you need to pay for your power, for your cooling system, for your ISP provider, internet provider. So you need to pay. There are several things, several maintenance aspects. Then you need to pay for the people who are looking into the maintenance of those servers, right? So these all things comes when you are going for a physical data center or a on-prem data center. So using cloud, the main advantage is pay as you go model. Okay, then the first cloud service that is launched by Amazon was in 2006. So the actual technology which they are developing, the cloud computing was developed from 1996, but they have launched it, the first service called Elastic Compute Cloud in 2006. Later in 2008, it became more. They have developed few more services like S3 and all. It became very famous. From 2010, I think, then we have different cloud service providers coming up. From 15, they have launched their own, different cloud providers launched their own services. Now it is very popular. Now when we talk about cloud, there are some futures. Okay, these are the 7 futures that the cloud will have. Okay, so I have named it as AWES. Have some futures. So A implies Availability, W implies web access or internet access, E implies elasticity, S implies shared resources, O implies on-demand self-service, M implies measured services, and E implies economical. Now, availability is the major thing. So when I talk about availability, 24 bar 7, the data or the services to be available to the client. So for example, you have a client and you have onboarded his resources to the AWS or any cloud environment. Now whenever the client need to access his resources, it should be available. For that, there is something known as SLA, service level agreement between AWS and the client. So this service level agreement is that generally the availability of AWS cloud is 99.99%. Okay, so if I say 99.99, it comes around say in a year it comes around 3 hours of downtime or 4 hours of downtime. Even I can show you that calculation. Give me a minute. Yeah, if you see 99.99 means it says 5 minutes of unavailability per year. If AWS says my SLA is 99.99, then you need to think in that way that 52 minutes you'll have downtime in a year. It cannot cross more than that. If it is crossing more than 52 minutes, then the SLA breaks and AWS needs to pay for the client, right? So because of this availability, you can say that only 5 minutes in a year there will be downtime, which is very minimal. Okay, if you take your own data centers, so to achieve these kinds of availability, you need lot of resources. You need lot of say different power sources. Not only if one power source is down, then you need one more power source for backup. Similarly, you need cooling systems. You need people to maintain these servers. So there is a lot of overhead. If you take cloud, this entire SLA is maintained by the cloud service provider. That is one of the advantage here. Now coming to web access. So you can access, like say, for example, if you go to Flipkart and buy some product, then you will add it into cart and then you'll buy it. Similarly, here also we have a web portal where we can log in and we can rent the servers or rent the database, and you can pay for whatever you are using. Okay, it's you have a web portal for that where you can access your resources remotely. Then elasticity. Say, for example, there is a big billion day sale coming up in next week for Flipkart. Now, what they will do, they will rent the servers from these cloud providers. Okay, for the specific period of time for one day or like a 1 week. So what happens whenever there is a load, so they use these servers, extra servers, to use basically to get the traffic, okay, into these servers. Otherwise the servers will get over limited, overburdened, and they will stop working, right? So elasticity is very important. Based upon the load, it should scale up and scale down. Okay, that is possible in cloud environment. In AWS we call it as auto scaling. Then shared resources. So just 1 minute. Okay, so then we have shared resources. Shared resources means, so since we are in a public cloud, we can share resources with, say for example, I have company A and I also have company B. Now what happens, I can share my resources with my both of the different branches of my company. Or since we are in public cloud, different companies shares the resources, so that the cost factor becomes less for us. Okay, it is economical for us. Then on demand self service. On demand self service means, as I told you, you have a project that is coming up in next 3 months. Now you need to decide what kind of hardware you need and what kind of database servers you need, what kind of capacity you need, right? Storage capacity. Now instead of there is something known as capex and opex. Capex is capital expenditure and opex is operational expenditure. So if you go for on premises, it's mostly of capital expenditure. Means you will assume, or you will know that the project is coming in next 1 year, and accordingly you need to recruit the people, or you need to have the hardware, or you need to have the resources accordingly, right? Here in in cloud environment, it's morely OpEx, because you are getting it in on-demand self-service, right? Whenever you want, within a click of a button, you are getting the resources. But in on-premises, that's not the case. You need to have upfront costing. Like, you'll have upfront cost, that is called as capex. You need to decide in the beforehand what are the resources you need, what is the technical, on the technical point of view, what is the capacity of a virtual machines or servers unit. You need to decide it in upfront. Okay, that is capex. And opex is like operational. You will only have operational expenditure. Okay, means whatever you are using, will pay for that. Okay, you don't have any upfront cost in opex in in cloud environment. Okay, then you have measured services. Measured services means, as I told you, it is pay as you go model. So for example, you are using a service for a specific period of time, then at the end of the month, the billing is generated. You need to pay according to the bill. Okay, according to your usage. Okay, similarly economical, since it is a shared platform, and so anyone can host their uh, servers or resources in the cloud, and it is shared, so it is economical for the companies. These are the futures of cloud. Any doubt here?
Sorry, just one
Uh,
thing.
Yes, yes.
Yeah. So on the economical part, right? Like, can you explain, maybe taking an example? For example, say if I have
Okay.
5 virtual servers to maintain my application,
Yeah, sure.
maybe the cost could be XYZ
Hmm.
dollars. What would be the same thing if I want to host it in cloud, or I mean any ratio as such?
Yes, yes. When I say economical, in cloud also, there are different virtual machines. There are something known as spot instances. Means spot instances means they will be for a specific period of time. Say for example, you need it only for 7 hours. Okay. So what AWS does is that they will reserve that particular instances for your company for 7 hours only. After 7 hours, they will automatically terminate. Okay, for this the
Okay.
cost is less. Okay, and there is something known as reserved instances. Say you have a project that is coming in next 1 year. You can reserve today for that project coming in future in AWS, so that the cost becomes less, because you are reserving from today, right? So that AWS will reserve it you for that specific after 1 year. Say you'll be saying, I'm getting a project after 1 year. I need 100 virtual missions to be reserved for my company. So what AWS will do, they will reserve these 100 virtual missions on your company's name for that particular after 1 year. Okay. Now, if you are buying it now and if you are paying it now, so that what happens is that AWS will decrease the cost of the virtual missions for that 100. In that way, it is more economical. Okay, there are different types of plans that you can buy, like reserved, then you have spot instance, and you have different types. I will explain you when we go to EC2. In that point, it is economical. And there is one more point, when compared to on-prem. Say if you are going to on-prem, if you want a server, okay, you need to pay. If you are taking an OS as Microsoft, then you need to pay license for Microsoft. Then you need to pay for the server and the server maintenance to make the availability as up 24 bar 7. Then you need to pay for the people who are maintaining that server. Then you need to pay for the power, then the ISP, then the cooling system. So all these things comes into the cost factor if you're going for on-prem. So if you take only the machine, you'll get the hardware cost, then the OS cost, then the patching or like what updates that has to be done, or any security mechanisms, or like firewalls and all these things you need to implement, right? To be secure, to make the resource secure. So these all comes there. If you come to the cloud, all these are offered by cloud service provider. The infrastructure, like the firewalls, the security groups, everything is offered by service provider as a pay as you go model, so it is economical.
Right. Okay. And one thing not related to this topic, but maybe can you later explain who are the major players? And you're mostly mentioning about AWS, right? So
Yeah, I will
if that,
explain
yeah.
in further slides.
Okay. Yeah. Thank you.
So yeah, these are the major vendors like AWS. We have Microsoft, Oracle, IBM, and Google. So if I want to rate, number one is Amazon. According to the market, it is having close to 70% of market in today's world. Okay, Amazon. First is Amazon. Second is Azure, then Google. After that, Oracle. and fifth is IBM. Okay. Now we'll see in cloud computing, then we have service models and deployment models. Service model, we'll discuss, there are three types of service models: infrastructure as a service, platform as a service, and software as a service. Okay, means these cloud providers are offering different kinds of services that we call it a service model. Okay, then we have deployment models. In deployment models, there are different ways of deploying your infrastructure. You can deploy in public, which is shared by every company, or you can create your own cloud environment for your company, for your client separately, and you can deploy there. Hybrid, which is a combination of both. I will explain that, basically the difference, why many people are going for hybrid. Okay, I will explain those, and then we have community cloud. Okay, before going to service models, so first let us see about the on premises. So if you see the on premises, here I have divided, here you can see this picture, this particular chart is divided into two parts. This is you manage and this is managed by Microsoft. So the blue one is which we have to manage. If you take on premises, all these things we have to manage from the networking point of view: storage, servers, the virtualization, the OS, patching and everything, middleware, then the runtime of your applications. Okay, then the data, application availability. So all these things has to be maintained by the company itself in case of on-prem data centers. If you take cloud environment, then it is divided into infrastructure as a service, platform as a service, and software as a service. So if you take infrastructure as a service, the underlying hardware, okay, the underlying server, storage, networking, and hardware is managed by the service provider. Then the OS, the application, the data, you have to manage. Means you need to decide which OS you want. Okay, you need to decide what application dependencies you want to install. You need to decide what kind of data you want, or what kind of database you need to deploy there. So these all things you need to manage. Okay, I'll give you a simple example. If you are trying to make a, say, a coffee or something. Okay, for that, what you need a gas, a stove, and everything, right? So consider the gas and stove is provided by, in infrastructure as a service, the gas and stove is provided. Okay, you need to, you need to get the vessels, the milk, and everything. Okay, so if you take platform as a service, what happens is that they will give the vessels, milk, everything. Then you need to bake, you need to cook it, or you need to, okay, boil it, and uh, add all the coffee powder or whatever it is. Okay, if it is a software as a service, you'll directly go to CCD and buy a coffee. So it's like that. So if you take a platform as a service, as I told you, you are responsible for your data and applications. Okay, when I say applications, so what happens in platform as a service is that they will offer the hardware along with the OS and the runtime, the dependencies, or the, say, for example, if you want to run a MySQL database. Okay, now what AWS does is that it will offer the entire package along with the hardware, along with that particular, along with the particular MySQL software. It will give you. Now what you need to do, you need to input your data tables into MySQL and connect it to an application, right? So you are only responsible for your applications and your data. Rest everything is taken care by the service provider. If you take software as a service, everything is taken care by the service provider. Example is like your Gmail or your Outlook, right? So these are present in Gmail's data center, or like Gmail's cloud environment, right? Now they are giving it as a service for that, for our company, and we are using it. We are just logging in and we are using. We don't know what application they are using in the background, how they are securing the data, what OS they are using, what infrastructure they are using. We don't know any of these. We are just logging in and we are using, right? That is software as a service. Now, if I give an example of these three platforms, if you take infrastructure as a service, then we have EC2, we call it as virtual machines, right? So these virtual machines, the hardware is provided by this cloud provider. Just you need to choose which OS you need. Then you need to install the dependencies. Then you need to install your application. Then you can use it. Okay. If you say the platform as a service, then the best example is that if you go for Azure, they call it as App Engine or App Service. In Google, they call it as App Service. in AWS Beanstalk, they call it as Elastic Beanstalk. So what happens here is that they will offer it as a service. Just you need to input your code, okay, or input your data, and the application will become up. Okay, the servers, the application servers are offered ready-made to you. The only thing you need to do is that you need to push your code. It can be automated by a GitHub or any other mechanism. Okay, you need to push your code into that particular service, and it will automatically up the application, because there is an inbuilt application server present in that particular underlying hardware. Okay, now software as a service, as I told you, it's like Gmail, Outlook, all your Google apps and Microsoft Office 365 apps comes under software as a service. So any doubt here?
No, sir.
So I'll just give you one more example of platform as a service. I'll show you like how generally it will be. Okay, now I'll just go for EC2. So this is a service in AWS to launch virtual machines. Okay, why I'm saying infrastructure, I'll just show you. This comes under infrastructure as a service because you are choosing the base infra, right? So the base infra is provided by the base infra is provided by cloud security provider. Just you are choosing them here. So for example, here you are choosing which kind of OS you need. Okay, for example, I need a Ubuntu or Windows or whatever it is. I'm just selecting the OS, and I'm just selecting the hardware capacity I need, right? And I'm just adding the security net the hard disk, how much of hard disk I need. Then I'm adding the security to who are allowed to access the server. I'm just creating this infrastructure as a service. Now we'll see platform as a service. This is a managed database service by AWS. We'll see like why we call it as a PaaS service. Now, for example, if I want to create a database, okay, so create a database. Now it is asking which kind of database you need. You need Oracle, MySQL, Postgres, or MariaDB. So these kinds of options it will give you, and it will give you other settings like what kind of capacity you need, what is the username and password you need. You can see you can decide your capacity. You want say 8-core CPU and 32 GB RAM. What kind of capacity you need, and storage how much you need, and the availability. You need multi zone or single zone, and security group. Then it will give you the cost, and then you can create. Now the major difference here is that generally what we will do, as I showed you before, okay, we will create a virtual machine. On top of it we install a database server. In general scenario, in on-premises scenario, we will have a virtual machine. On top of it we will install a database server like MySQL or whatever it is. Okay, now what they are doing, they are offering it as a service for us. See that when you click MySQL and click create instance, MySQL will be automatically deployed. Okay, they are giving the underlying platform for us. What you need to do is that you need to just insert data in it or your tables in the database. Okay, so this is the reason we call it as a platform as a service. They are offering you an underlying platform to develop your application or to create your own database. If you are going for infrastructure as a service like EC2, what do you need to do? You need to deploy EC2. Then upon that, you need to install your database server. After that, you need to deploy your data in it. Okay, that is a major difference. Understood? Okay. So then coming to deployment models, we have public, private, and hybrid cloud. So these are the major difference between all three of the deployments. So if you take public cloud, services are owned and operated by third-party providers. Like these is a sharing platform where different people can deploy their resources in a public cloud. If you take hybrid, it is to a single client or if you take a private cloud, it is dedicated to a single organization. Okay, that is private to that organization, which is more secure compared to the public cloud. So if you have more data sensitive applications, generally we go for private cloud. And if you don't have more data centric applications, data sensitive applications, then we'll go for public cloud. Okay. So if you see the public cloud, the maintenance is paid by service provider because they are handling entire hardware backend for you, and it is pay as you go model, and it is less secured compared to private cloud. And the flexibility and control over the cloud environment, less flexibility and control over the cloud environment because it is shared. So underlying hardware and everything is maintained by the cloud provider. So we have very less uh, flexibility on managing those hardware. If you take private cloud, it is more expensive compared to public because public is sharing platform, so that it is not that expensive. Private is specifically for your own company, so it is expensive. Okay, but the security is high here because it is only shared with your company. And again, the to set up private cloud, you need to maintain your own DC there, or you need to go for any providers like VMware, who offers this private cloud. So the cost and maintenance will increase here. And coming to the hybrid cloud, so hybrid cloud generally is a combination of public and private cloud, or on-prem and public cloud. It can be on-prem public, or can be private public combination. Okay, that we call it as a hybrid cloud. So the advantage of this is that there is no vendor lock-in. What is vendor lock-in is, for example, you are in AWS cloud, now you want to move to Azure cloud. So it is very heavy lifting for your company to move entire cloud resources to other particular cloud resource, right? So basically there is a vendor lock-in. You are locked with that vendor. Okay, you can move, but it is very troublesome and very expensive for your company to move at a time. Okay. Now, for that they have introduced this hybrid cloud. Hybrid cloud means what your company will do is that it will segregate the resources or clients in different say clouds. Say for example, it has clients in AWS, then Google Cloud, then Azure. Now it is easy for the company to move the resources across different clouds. Okay, if AWS is down, for example, if AWS cloud is down, then they can offer services to the clients by their product that is deployed in Azure or Google Cloud. Recently, I think around 2 or 3 months back, AWS, some of the regions of AWS was down. Okay, in that case, what company can do, they can leverage the product that is deployed in other clouds and provide the services to different companies, right? So in that way, hybrid cloud can help us to come out from the vendor lock-in issue. Okay, it gives more flexibility and more deployment options. Any doubt here?
Also, like, can we say maybe companies who are in transition phase from on-premises to cloud, is that also hybrid?
If you say for transition, if it is a complete transition, then it's not. If they are using on-prem as well as any of the public cloud, then we can probably call.
Okay.
Okay,
And
if
what
they're
is cloud
complete,
bursting? Sorry, there is. Yeah.
yeah, cloud bursting is that it will improve the performance. Okay,
Okay.
hello,
Yeah, I think you're breaking out.
hello.
Yeah, can you hear me?
Yes, Sai, we can able to hear you.
Okay, so for example, if you have an application, okay, consider that is in your private cloud. So what it can do is that it can try to access, okay, the database server that is deployed in a public cloud. Okay, so these kinds of inter cloud can be happening. That in one sense, that is also called as cloud bursting. So your applications present in a private cloud can access the database server that is present in another cloud. So the cloud bursting is possible here, which can improve the performance.
Okay.
Any other doubts?
No, Sai, you can continue.
Yeah, yeah. And one more advantage of this cloud busting is that, for example, now the load on your machine is increasing. Okay, now what happens is that it will automatically scale irrespective of the cloud environment, right? That is one of the advantages of cloud busting. Now let us talk about community cloud. So there are four types actually: public, private, hybrid, and community. Community is actually specific to the organization. Say for example, you have similar kind of organizations like if you take healthcare, hospitals and all. So their working, the compliance model they follow is similar, and their working model is similar. So they can club together and form in a cloud. Okay, that can be called as community cloud. Okay, this is not widely used, but yeah, there is a type this as this as well. So the major disadvantages of cloud computing, okay, lack of security and privacy, because the underlying hardware or our data, everything is managed by the cloud security provider, right? So we don't have any access to the underlying components. So the entire security is taken care by the underlying hardware level security. In case of infrastructure as service, if it is a PaaS, the entire till the OS layer, the middleware, the entire security is handled by service provider. If it is a SaaS, complete end to end is handled by service provider. So the lack of visibility and the privacy issues will come up in terms of using the public cloud. Okay, that is one issue, because we don't know what kind of mechanisms that a cloud service provider is using in the backend. Okay, in their hardware level security or in their hard data level security. Okay, so that kind of visibility we don't have. Then limited control. So since the CSP owns and manages the entire infrastructures, cloud customers will have minimal controls. As I said, we don't have much control to the environment, like to the data centers or to the servers. Okay, we don't have much control to it. Then the third one, lock-in, which I have explained. So in case you are with AWS or you are with a specific cloud, to move or to transition from one cloud to another cloud is very troublesome. Okay, you cannot transition at a go, or you cannot transition immediately within a less time to other cloud. So basically you are locked with one vendor. Okay, so if you want to transition, the cost may go up very, that cost of transition will be very expensive. Okay, so it's better to go for a hybrid environment, hybrid cloud environment. Okay, then we'll go for virtualization. Okay, what do you know about virtualization, or have you heard about virtualization? Any idea? Okay, so the underlying technology that is used for cloud computing is called virtualization. So what is virtualization is that, so virtualization is again a software that will be used to virtually use the computing resources. Say for example, if you have a server, what you can do, so you have a free space of 4 GB RAM, and you want to utilize the remaining cores as well, CPU cores as well in your machine. What you can do, you can use this virtualization technology, and you can install that software. What you can do, after installing the software, you can use these resources, hardware resources of the host machine virtually. Okay, so this enables IT organizations to run more than one virtual system and multiple operating systems and applications on a single server. These results benefits include economics of scale and greater efficiency. So you can use your underlying hardware to launch various applications with various operating systems on a single server. Okay, that is virtualization. For this, we use something known as hypervisor. So hypervisor is responsible for virtualization. Hypervisor is a software. So there are two types of hypervisor softwares. One is type 1, type 2. So if we talk about type 1, we call it as a bare metal, and type 2 is VMM, or we call it as hosted virtualization. So if I talk about type 1 virtualization, then you have base hardware. Okay, consider you have a bare metal like a server that has to be deployed. Okay, now you have a server. Upon that, what you will do, you will install an hypervisor type 1 software. It can be VMware EXSI or Hyper-V or Gen. Okay, so these virtualization softwares, what they can do, they will once you install this, you can create several virtual machines on top of it. So here you don't have a dedicated OS. You don't have a dedicated OS for your hardware. Okay, for example, if you take your PC, what you will do generally, you have your PC and you have your Windows OS. On top of it, you will install VMware or VirtualBox. On top of it, you will deploy your virtual machines, right? Here, if you take type 2, this is considered as an for our testing purpose or our own say our own laptop or our own systems, okay, our PCs. In our PC we have hardware and we have base OS, right? Here we have hardware but we don't have base OS. The OS along with hypervisor software comes within a package. If you take VMware has its own OS that supports this hardware along with the virtualization technology, okay, along with the hypervisor software, right? So you don't need a separate OS here. If you take our own PCs, we have hardware, then we have host OS. On top of it, we install VirtualBox or whatever it is, VMware workstation. On top of it, we deploy our virtual machines. Okay, this is the major difference. Understood? This is for servers. This is for our hosted machines. So you go here. So if you take this server, okay, it has 6 TB of RAM, 24 uh, of slots there. Then it has 28 cores of CPU. Okay, now what we will do, we will on top of it, we will install VMware EXSI, the software. What happens? This comes with the OS that supports this hardware as well as the hypervisor software. Once you install this, now you can deploy your own servers. I will show you the console. How does it looks like? So this is how it looks like. I'll just zoom in. So this will be your base server. On top of it, you will install different servers. Okay. Like you can see virtual machines, then you have storage and networking. So you can have different virtual machines on this particular base host. This is VMware EXSA software that is deployed on this particular base server, okay, which I have showed you in this picture, right? On top of it, this is installed. Once this is installed, you can get this console where you can deploy several virtual machines by calculating what amount of CPU you need and what amount of storage you need. Accordingly, you can deploy your virtual machines. Till the complete space consumes, you can deploy whatever virtual machines you need. Okay. So this is type 1 virtualization. If you take type 2, I can give simple example of your say your desktops or say your laptops where you have Windows or Mac or Linux OS. On top of it, what you will do, you will install VMware workstation or Oracle VirtualBox, and then you will allocate the resources. You will have your ISO file, then you will deploy your virtual machine. Is it clear?
Yes, sir.
Okay.
I have one doubt.
Yeah.
Where can we use hypervisor? What is the scenarios where are the scenarios?
Hypervisor is software, right? That is
Yes.
responsible for virtualization. Hypervisor, as I told you, if it is a physical server, you use VMware EXSI. So using this hypervisor technology, many vendors has created softwares like VMware EXSI is one type. Then you have Hyper-V. These are different vendors, right? So
Yes.
that is nothing but the hypervisor softwares.
Okay.
So hypervisor is nothing but a software. For that, we have different vendors like VMware EXSI, Hyper-V, Gen, and all. Okay.
No, actually, my doubt is what are the scenarios we can use hypervisor?
We will use hypervisor for virtualization. That is the
Oh,
only way which we can use.
oh, okay.
Then coming to advantages and disadvantages of virtualization. First thing is that you will save money because you are using the base hardware to create number of virtual machines, right? So that in that way you will save the money. Then simplified management. So if you have an individual server, what happens? You need to maintain all these individual servers. Okay, that is like overhead for us. Now, in one physical server, if you have 10 machines, okay, it is easy to manage, right? Because you'll get all this in a single console. From there you can start it, stop it, restart it. If you have individual server, you need to log in into each server and manage them. Okay, that is one advantage here. Then threat isolation. Say for example, one virtual machine is compromised or it got affected, then you can terminate that or you can remove, so that your base OS and other virtual machines are protected, right? So that is one scenario. Then backup and recovery. In backup and recovery, we can take a screenshot, snapshots, right? So we can take snapshots, which maintains the state of the virtual machine, and you can restore to that state. Okay, you can recover to that state. So that is one advantage of virtual machine. Then coming to disadvantages, because you are using same physical server, okay, to host n number of virtual machines, the performance is compromised here. Yes, because you are not using individual machine, you are using same physical hardware to deploy several virtual machines, right? So the performance can be an issue here. Okay, then complexity. So since you have these many virtual machines, it is bit complex while coming to maintain them. For example, say you have different network interfaces, okay, that you need to configure for each virtual machine. Then you need to assign resources for each virtual machine, and you need that specific skills. Okay, for example, if you take a Windows for administrate a Windows administrator, so you need the skills regarding Windows. But in virtualization, you need skills regarding the VMware as well. Or if you are using VirtualBox, you need those skills. Okay, you need extra skills for that. That is one thing. Then risk. Say for example, your base hardware or base host is compromised, entire machines are compromised, or entire, if the base OS is failed, okay, if the base server is down, entire virtual machines are down. Okay, that is one of the major disadvantage. Then we'll see the components of AWS. As I told you, there are different components in AWS. So to host your application, there are several services that are responsible. Okay, first thing is that your infrastructure, that they have divided it into three types. Okay, regions, availability zones, then edge locations. So regions are cities, availability zones are data centers in that city. Okay, then edge locations are like every region has an edge location which will catch the application data so that it is easily accessible. I will explain detail of about regions, availability zones, and edge locations. For that, for now, remember this is the data center level, physical level. Then you have foundation services like infrastructure as a services like EC2. Then S3 is actually managed by AWS only. It's a global service. Then you have database, networking. Then you have several like content delivery, you have CloudFront. Then you have several services, right? Then you have management services, IAM and all. Then you have your application. Okay, these are several components or several services of AWS. Then this is very important. So this is called shared responsibility model. Now what customer is responsible for security in cloud and what AWS is responsible, that we call it as responsibility for security of the cloud and in the cloud. In the cloud for customer and off the cloud for AWS. So if you take AWS, what it is responsible for in terms of security is that the hardwares, the regions, availability zones, means it need to take care of the availability of the data centers, right? That is nothing but regions, availability zones, and edge locations. Then hardware like computing, storage, database, networking, the backend hardware for this has to be maintained by AWS. Okay, in terms of security. Then customer is responsible for his data, and he is responsible what level of access he is granting for the users, and he is responsible for OS level vulnerabilities and all. Then he is responsible for networking, firewall configuration, then encryption, authentication, and all these mechanisms. Okay, now let us see about regions and availability zones in AWS. So in AWS, actually we have 26 geographic regions. Then we have 84 availability zones. Means every region can have more than one availability zone. Okay, one is minimum, and maximum till now I have seen maximum of six availability zones per region. Okay, means 6 data centers in one region. Now region is nothing but a city. If you take Mumbai, we have 3 availability zones, means 3 data centers in Mumbai. In case one data center fails, the other data center will use other data centers to access our data. Okay, our data is replicated across all the data centers in that region. I will show you with an map.
So this is more like disaster recovery in
Yes,
on-premises,
kind
is
of,
it?
yeah, correct. So, okay, 1 minute. AWS. So if you take, yeah, if you take Asia Pacific, okay. Now the yellow part, okay, that is regions. Okay, then here it is given as edge locations. Okay, so and we have availability zones. For example, if you take Mumbai, okay, so consider region as city, not as a country. Okay, consider region as city, not as a country. If you take Mumbai, in Mumbai we have 3 availability zones. Means in Mumbai we have 3 data centers. In case one data center fails, okay, we can access our resource from other data center. All these data centers are connected. Understood, right? So
So I have one doubt here.
yeah.
If one data center fails, whatever data in that data center that will be replicated, or
So actually, there are two types again in this. So you need to choose. You want your data to be present in all the availability zones, or you want your data to be present in a single availability zone. That
okay,
is something depends upon the costing. Okay, if you choose a single, say data center, the cost will be less. If you're choosing more data centers, then the cost will be high. If you take S3, that is a global service, so it is stored across. To take EC2, you need to choose where your virtual machines to be created. Okay, you need to choose the data center. If you are choosing more than one, then there will be costing involved.
okay,
So, so if you go to this particular site, you can see different regions, and in that regions, what are the data centers that it is having. Data centers are availability zones, and the city we call it as a region. Every city has a unique code. I will show you like how can we see that and everything. Okay, in the later session of the class. So now I will show you the dashboard overview. How does the dashboard looks like, and how can you create your own AWS account? Okay, first you need to log in. You need to go to aws.amazon.com. Then you have a create an AWS account option. Click on that. Then you should give your email ID and your account name. Once you verify your email ID, okay, it is asking verification code. Once you give verification code, so the next step will be, let me give any other email. So that you'll come to know. Okay, it is asking the verification code. Once you give the verification code, then it will ask your name, details, everything. Then it will ask you your payment details. You can use your debit card. Then you can create. Once it is created, within 24 hours, all the services will get active. Okay, so it is very simple. You can just click next. Then there will be payment details. You can fill the payment details, and you'll get access to AWS. Then once you get the access, you need to log in. For logging in, you need to click sign in, right? Once you click the sign in, it will ask you root user. You are the root user, right? IAM user is nothing but in your account you can create a sub users and give access to them. That is nothing but IAM user. Since you are logging in as a root, you should give your root email address that you have done while creating AWS account, and then you need to give password. Then you will get a console. like this. Okay, you'll get a home page like this. Now when I say regions, these are the regions. Okay, if you take US, you have US East, North Virginia, Ohio, California, Oregon. Okay, for this they have given the codes: US East 1, East 2, West 1, West 2. If you take India, you have only in Mumbai, which is AP South 1. If you take Europe, you have Central 1, West 1, West 2, South 1, West 3, okay, North 1. So these are the codes given for that. Now, if you take North Virginia, for example, I'm selecting the region as North Virginia. Okay, now it will reload and it will move to that region there. Okay, now I want to see the availability zones in this region. Then just click on EC2, or you can search via the search bar. You can just type EC2. Okay, now you can see the availability zones present in that region. Means these are the data centers that are present in the region, and you can check the health. Okay, in case any of the data center is down or not, you can check the health here. No issues at present. AWS is saying there is no data center that is down. Okay, these are the availability zones present. You can deploy your resources in any of the data center as per your wish. Okay, so this is an overview of the dashboard, and you have different services here. Once you click the services, you have different services. You have service related to robotics, then networking, then media, Internet of Things, machine learning, so security, compute. So you have different services. If you click on compute, then you can get these services here. Okay, so this is done. Then yeah, so this is the final topic today. I will just show you few important things before we go. Let me just show you. Okay, now IP, yeah, AWS IP ranges. For example, I'll go to Google and I will type AWS IP ranges. It will give me a document of AWS. Once you go into that, there is an option to see IP ranges.json. Now, if you see this, these are the IP ranges that different IP ranges that are used by different data centers or different services in AWS. If you see here, it is AP Southeast 1. Okay, this is EU Southeast 1. It will use these kinds of range. It will use this particular IP range. If you want to search for a specific service, for example, EC2 for virtual machines. Okay, now there are 1160 ranges according to different availability zones. Means different data centers use different ranges of IP ranges. Okay, you can see there is /16, /24, /14. Okay, now what attackers will do is that they will scan these IPs. Okay, they will scan these IP ranges and they will try to find the open servers or open buckets or say misconfigurations of these servers. Okay, for example, I will show you a site that will scan and that will give you the results. So what we'll do, so this is a gray hat warfare. Okay, here if you see, I'm just giving random buckets here, or I can search a keyword. For example, I want a secret that is present in any of the AWS cloud account that is opened. Okay, let us see. I want this file. So you can see this many hits. You can see 1 lakh hits. So here you can see redpath.s3 amazon.com, and there is someone, they are using secret keyword, and this is publicly exposed. That is the reason we are able to see. Understand, right? So, and if you see here, the secret life, there is some JPG that this keyword is used, and this particular bucket is nothing but a storage. Like Google Drive, we have a folder, right? In Amazon, we call the term here is S3. In that we have buckets, nothing but folders and files. Okay, and we call them as objects. Files we call them as objects, and folders we call it as a buckets here. Now these are externally exposed to internet. That is the reason we are able to see the data inside it. right? How they are getting this data is that they are scanning all these IP ranges, which I have showed you here. By scanning these, they are trying to do the pen test. Means they're trying to do whether can we compromise this open server, can we get the data out of it. So these tools are doing that, and they are getting the data for us. If you want to see the buckets, then click on random buckets, or if you want to search for a specific bucket, you can search. So these are the open buckets, right? And these are the files present in that bucket. Okay, you can randomly search files, or you can search buckets, or whatever you want, you can search. You can see these are the buckets. Then you have for Azure cloud, you have it for AWS cloud. So total 8.015 billion files that are present open. Okay, these can be this is because of the misconfiguration. Say you have an admin, and he doesn't know the proper security controls, or you developers, they might don't know, or there is a fresher, like, or a new person who is trying to learn AWS, and you don't know proper security controls, and his data is exposed, or his servers are exposed, right? So there can be any reason. Okay, there can be any reason. It can be misconfiguration, or that is unintentional or intentionally done, or an attacker tried to compromise, or a person without no security knowledge exposing these resources outside. So this is how these scanners basically scan the IPs and get the list of files or buckets that are open to internet. You can search via it. It is actually paid. To search, it is free. If you want to access the data in that, you need to pay for that. This is subscription based. And there is one more called Shodan. This basically scans the resources and gets the open servers. For example, I'm giving S3 website with this name. Okay, now let us see if we can get any of the, yeah, we have many open servers, right? Now I'm opening one of the server. Let us see what we can access. So we can access their code here. See, we can access their website basically, that is hosted on a bucket. So here one more feature of AWS storage is that you can host your website, basically the static website, on the storage. But if you take Google Drive, we cannot host there, right? So there are some advanced features in AWS storage. So these people are hosted their websites on this S3 bucket, and they kept open to the world. That is the reason you are able to access the buckets, or they have not given the proper controls. Okay, so we can use Shodan, or we can use different ways of doing our information gathering here. Okay, now these all about it, and I will take one more minute of yours, and I will just take you through the recent attacks in 2021. In 2021, there are several breaches that has happened to several companies, right? If you take MobiKwik, India's digital payment provider, KYC data, including passport copies, transaction logs, email address, phone numbers are leaked. Okay, around 10 million data. So there are several attacks that are happened, mostly to misconfigurations. So there is a report that says 90% of attacks in clouds are due to misconfigurations. Okay. So I will show you the statistics here of 2021. So here they are giving the cause of misconfigurations. It can be due to lack of awareness of cloud security and policies. It can be due to lack of controls and oversight, too many APIs and interfaces to adequately govern, or negligent of insider behavior. These are the major reasons for misconfigurations, and they have given the percentage of it. This is for 2021. Okay. So there you can go through this report. I will share you this PPT. Just you can go through this report and understand more what is the cause of these cloud misconfigurations and all. So they are giving by type. So so many people, due to lack of firewall controls or network controls, 44%, lack of IAM, identity and access management, 40%, then lack of encryption and encryption at rest disabled, 36%. So they have given entire report here. You can just go through and ask me if you have any doubts here.